In July 2012, the Sun fired the largest plasma cannon it had loaded in 150 years, and the shot passed clean through the patch of orbit Earth had been standing in about a week earlier. We survived the apocalypse on a technicality of scheduling. NASA wrote it up in a report that landed with all the public urgency of a software update nobody asked for, and the world carried on with its afternoon. Had that shot connected, it would have flattened power grids, cooked satellites in their orbits, and switched off the internet. Not for an afternoon, but for something closer to a year. And the genuinely unsettling part isn't that this is hypothetical. It's that the exact same thing has already happened once, and the only reason it didn't end us is that we hadn't yet built the thing it destroys. To understand why a good day on the Sun can ruin a decade on Earth, you have to drop the comforting idea that the Sun is a calm, dependable furnace in the sky. The Sun is 1.3 million Earths worth of exploding hydrogen, held in a ball by nothing but the crushing weight of itself, and its magnetic field lines are perpetually twisting into knots like a pair of headphones left alone in a pocket. Every so often, one of those knots snaps, and the Sun loses its temper in one of two ways. The gentler option is a solar flare, a flash of radiation that crosses 93 million miles and arrives at the speed of light about 8 minutes later. The serious option is a coronal mass ejection, which is the Sun tearing a billion-ton chunk off its own body and flinging it into space at several million miles an hour. The flare is the muzzle flash. The ejection is the cannonball. Most of these cannonballs miss us because space is mostly empty and Earth is a small target. But the Sun fires thousands of them a decade, and we are, in the most literal sense, living inside the range. It also runs on roughly an 11-year mood cycle, and we have just come down off the latest peak, which, historically, is exactly when it tends to throw its worst tantrums. We know precisely what happens when one of these connects, because one did on the morning of September 1st, 1859. A British astronomer named Richard Carrington was at his telescope sketching sunspots, which in 1859 passed for an exciting hobby when two blobs of blinding white light flared up brighter than the rest of the Sun. He ran to fetch someone to confirm he wasn't hallucinating, and by the time he got back, it was already fading. He had just become the first human to watch the Sun pull the trigger. A coronal mass ejection normally takes 2 or 3 days to reach Earth. This one made the trip in 17 hours, because an earlier blast had swept the road clear ahead of it, and the Sun had accidentally built itself an express lane. That night, the sky stopped behaving. The auroras, which normally keep strictly to the Arctic, drifted south until they were glowing over Cuba and Colombia, and gold miners in the Rocky Mountains rolled out of bed at 1 in the morning, decided it was dawn, and started frying breakfast. In New York, crowds climbed onto their rooftops to watch a sky several of them were fairly sure meant the world was ending. An understandable conclusion, just a few centuries premature. People read their newspapers by the light of it, while their compass needles turned in slow, useless circles. Then the pretty part ended. In 1859, humanity owned exactly one piece of electrical infrastructure, the telegraph, a continent stitched together out of copper wire, and the storm walked straight into it and set it alight. Sparks leapt off the lines, operators caught electric shocks at their desks, and telegraph paper smoldered into flame in offices on 2 separate continents. And then it got genuinely strange. Some operators unplugged their batteries entirely and found the lines still working, running purely on the current the aurora was pumping into the wires. 2 operators in Boston and Portland held a full conversation for 2 hours on nothing but the storm, and one of them noted, for the record, that the line actually worked better that way. That isn't a legend, it's in the telegraph logs. The Earth itself had been turned into a battery, and in 1859, the worst it could manage was a colorful newspaper story, because the telegraph was the only thing we had bothered to plug in. So here's the uncomfortable question. How much have you got plugged in? Because a geomagnetic storm doesn't go after your gadgets, it goes after wires, and the longer the wire, the more it likes it. When a coronal mass ejection slams into Earth's magnetic field, it makes the whole field shudder, and a shuddering magnetic field shoves electric current into any long conductor sitting underneath it. That isn't a malfunction. It's the exact principle every power generator on Earth already runs on. Which means that during a major storm, every power line on the planet quietly turns into a generator nobody asked for, feeding its homemade current into the transformers that run our grids. Those transformers are built to expect one specific kind of electricity. This is emphatically the wrong kind, and so they overheat, their copper melts, and a fair number of them simply catch fire. We have actually run this experiment by accident. In March 1989, a storm considerably smaller than Carrington clipped Quebec, and the province's entire power grid collapsed in 92 seconds, leaving 6 million people without electricity for 9 hours in Canada in March. That was the warning shot, and the part nobody enjoys hearing is that you can't pop down to a shop and buy a replacement for one of these giant grid transformers. Each one is custom built, costs millions of dollars, weighs about as much as a house, and takes 1 to 2 years to make. A Carrington-class storm could cook hundreds of them at once on every continent simultaneously, which would put the entire planet onto a single waiting list, one serviced by factories that also inconveniently need electricity to run. Once the power goes, the rest follows on a schedule. The first day is almost pleasant, a sort of enforced camping trip with no lights and no Wi-Fi. By the third day, the gas stations are dead because pumps need power, and the grocery stores are stripped because so does refrigeration. Within 2 weeks, the water treatment plants burn through their backup fuel, and within 2 months, nobody has been paid because your money is a number stored on a server in a building no one can power. The U.S. National Academy of Sciences sat down and modeled all this and put the damage at $1 to $2 trillion in the first year alone, with full recovery taking somewhere between 4 and 10 years. 4 to 10 years isn't a blackout. It's a different century, visited involuntarily. Quick intermission while civilization smolders in the background. If you're enjoying watching everything you rely on get switched off one system at a time, consider subscribing. We make one of these every week, it's completely free, and unlike the power grid, it has no known single point of failure. Now, the good news is that your phone will be fine. The idea that a solar storm reaches down and fries your personal electronics is a myth. The bad news is everything your phone quietly leans on. No grid means no internet in the obvious local sense, but the deeper problem lives on the ocean floor. The internet between continents runs through roughly 500 undersea cables, and while the cables themselves are fiber optic, pure light, completely immune to all of this. The signal fades over distance and has to be boosted every 50 to 100 kilometers by repeaters that run on good old copper wire, powered from the shore. Copper, long, underwater. By now, you can guess exactly what the storm makes of that. In 2021, a computer scientist published a paper on this precise scenario, gave it the wonderfully serene title, Planning for an Internet Apocalypse, and concluded that a superstorm could knock out enough repeaters to sever whole continents from one another. The internet handed an ocean-sized breakup, fiber and all. Space doesn't get off lightly either. In February 2022, SpaceX launched 49 Starlink satellites straight into a minor solar storm, which had puffed up the outer atmosphere just enough to add a little extra drag. And that little extra drag was enough to drag 38 of them back down to burn up on re-entry. That storm was officially rated minor. A Carrington event would not be rated minor. And the GPS satellites overhead don't just draw maps for you. Their atomic clocks are the invisible metronome that timestamps every bank transfer, every stock trade, and the synchronization of the power grid itself. So taking them out doesn't merely lose you directions. It gives the entire financial system amnesia. Add it all up, and you get no power, no payments, no GPS, and no internet between continents, at which point your phone still switches on perfectly well, as a rectangular flashlight that also tells the time. And the truly unnerving thing is how often we have nearly found all of this out the hard way. Take May 1967, in the deep freeze of the Cold War, when the United States kept 3 enormous radars pointed permanently at the Soviet Union with a single job: spot incoming nuclear missiles. One morning, all 3 went blind at the same instant, and a blinded missile warning radar, under Cold War logic, means the enemy is jamming you to hide a first strike, which is itself an act of war. The Air Force began readying nuclear-armed bombers for takeoff, this being the precise moment in the film where the music cuts out, when the military's brand new solar forecasters burst in waving a chart at the real culprit. It wasn't Moscow jamming the radars, it was the sun, screaming on the same frequencies. The bombers stood down, and the Cold War came within a few minutes of going hot over a sunspot. That, incidentally, is why militaries still fund space weather forecasting today, not for the convenience, but to avoid starting the Third World War by meteorological accident. 5 years later, the sun tried again, throwing a monster storm in August 1972 directly across the flight path of the Apollo program, threading the narrow gap between the Apollo 16 and Apollo 17 missions. Had astronauts been in transit at the time, the radiation dose could have been lethal. The moon landings dodged a catastrophe by about 4 months, twice. Then on Halloween 2003, another giant storm blacked out a city in Sweden, cooked transformers in South Africa, forced airlines to reroute their flights away from the poles, and sent the crew of the space station to shelter in its most shielded compartment. And then, of course, came 2012, the big one, which missed us entirely. The pattern is hard to ignore. The sun keeps firing warning shots, and we keep happening to be standing somewhere else when they arrive. Which leaves the only question that really matters. When does our luck run out? The scientists have an answer, and you are not going to enjoy it. The estimated odds of a Carrington-class storm hitting us run somewhere between 1 and 12% per decade. You would not board a plane offered those odds, and yet here we all are, permanently aboard, because the plane is the planet. Insurance companies file this risk in the same drawer as asteroid strikes, with the small difference that asteroids get blockbuster movies and the sun gets a shrug. And Carrington, unsettlingly, isn't even the ceiling. In 2012, a Japanese researcher found a strange spike of radioactive carbon locked into tree rings from the year 774, the chemical fingerprint of something that struck Earth that year, possibly 10 times harder than Carrington. Tree rings, it turns out, keep a quiet criminal record of the sun's worst behavior. The medieval peasants alive for the last big one came through it perfectly fine, on the strength of owning no technology more advanced than a bucket. We are not medieval peasants. We are the first generation of humans to wire our entire civilization into a single planet-sized antenna and then point it at the thing throwing the cannonballs. So, is anyone actually doing anything about this? The reassuring answer is yes, sort of. We keep a small fleet of spacecraft staring at the sun around the clock, so when a coronal mass ejection launches, we watch it leave and get somewhere between 15 hours and 3 days of warning. We even had a dress rehearsal recently. In May 2024, the strongest storm in 20 years hit Earth. The power grids mostly held, but GPS went wobbly enough that self-driving tractors across America began plowing crop rows that came out looking like spaghetti, and farmers lost roughly $500 million from a storm nowhere near the size of the big one. The emergency plan stripped to its bones is this. Power companies reroute their current and deliberately switch off their most precious transformers. Satellite operators put their spacecraft to sleep. Astronauts retreat into the shielded heart of the station, and then everyone waits to find out exactly how furious the sun actually is. So, to recap the relationship, the sun periodically hurls 1 billion tons of itself in our direction. In 1859, it set the telegraph on fire and briefly ran it on ghost current. In 1967, it nearly tricked us into a nuclear war. In 1989, it switched off Quebec in 92 seconds. And in 2012, it missed us by a single week, to near total public indifference. One day it won't miss, and the entire distance between fine and a decade in the dark is about 15 minutes of warning. The genuinely good news, and I'd like you to take real comfort in this, is that there is absolutely nothing you personally can do about any of it. Terrible news for civilization, admittedly, but a tremendous weight off your own to-do list. If you'd like more of the universe quietly trying to end you, our episode on nuclear power, the angry rock that runs the world, is also doomed and also fascinating.